Hey you guys, this is Mr. Millings, and in part 2 of this 3-part series on calculating thermal energy with a phase change, we are going to learn how to calculate thermal energy changes when there are two phase changes going on. And these are typically going to be 6-step problems. So let's jump right into a problem and take a look. In this problem right here, it says to calculate the amount of energy in kilojoules associated with the 150 grams of water vapor at 115 degrees Celsius turning into ice at -5 degrees Celsius. So what I like to do when we have these types of problems where there's changes in state of matter is I like to draw a little picture. And in this picture, it tells us that we have water vapor at 115 degrees Celsius. And the mass is 150 grams. So we have 150 grams of this water vapor at 150 degrees Celsius. And what's going to end up happening is that this water vapor is going to cool down. It's going to condense at 100 degrees Celsius. It's going to cool down further, and then it's going to freeze at 0 degrees Celsius. We know this to be the condensation or boiling point of water and the freezing point or melting point of water right here. And then this ice is going to continue to cool down to a temperature of -5 degrees Celsius. And what we want to know is how much energy, how much thermal energy or heat does this water vapor need to release in order to go from 115 degrees Celsius to -5. So this is going to be a 6-step problem, and our first step we'll have to do Q equals Cm delta T for our water vapor going from 115 to the condensation point. Right here at the condensation point, step 2 will be to figure out the heat of vaporization. That's the amount of energy this water vapor is going to need to release. And step 3, what we're going to have to do is use Q equals Cm delta T and figure out how much thermal energy this water is going to have to release as it goes from 100 to its freezing point of 0 degrees Celsius. And step 4, what we will have to do is figure out how much energy the water is going to have to release in order to just turn into ice, or calculate the heat of fusion. And step 5, we'll have to use Q equals Cm delta T here and figure out how much thermal energy this ice is going to have to release as it goes from 0 to -5. And once we have all 5 of these answers, we can just add them up. So let's jump right in here. Number 1, we're going to figure out how much thermal energy the water vapor is going to need to release in order to go from 115 to 100. So we'll use C times M times delta T here. Our specific heat capacity of water vapor is right here. It's 2.0 joules per gram degrees Celsius times the mass of our water, which is going to be 150 grams, times the change in temperature as it goes from 115 to 100. To do this, we take the final temperature minus the initial temperature. 100 minus 115 will give us -15 degrees Celsius. And so we'll put this in our calculator. We will put this in our calculator, and we will end up with 2.0 times 150 times -15, and we end up with -4,500 joules. Next step, we have to figure out our heat of vaporization, how much energy it's going to take to turn this water vapor into water, or how much energy will have to be released. And so we have, let's see here, 150 grams of water. We're going to convert this into moles. 1 mole of water is 18.02 grams of water. And then we know our heat of vaporization of water is 40.7 kilojoules per mole. However, this needs to be negative since we have water vapor cooling down and turning into water. It's going to have to release energy. So we put this in our calculator. 150 divided by 18.02 times -40.7, and we end up with 338.8, -338.8 kilojoules. This is in kilojoules. This is in joules. We'll fix that later. Step 3, we'll have to figure out how much thermal energy this water is going to need to release in order to go from its condensation point, which is 100, to the freezing point, which is 0. We'll use C times M times delta T for this. Our specific heat capacity of water is right here. It's 4.18 joules per gram degrees Celsius. times the mass, which is 150 grams, times the change in temperature. The temperature is going from 100 to 0, so we take the final temperature 0 minus the starting temperature, which is 100, and we end up with negative 100 degrees Celsius. And so we'll put this in our calculator, 4.18 times 150 times negative 100, and we will end up with negative 62,700. Now we have to figure out the heat of fusion, so let's do that. To get our heat of fusion here, we have to take the mass first and convert it to moles. So we have 150 grams of water. We know 1 mole of H2O is 18.02 grams of H2O. And now we need to multiply this by the heat of fusion, which is 6.02 kilojoules for every mole. This needs to be negative though, since the water is freezing. And so we'll put this in our calculator, and we will end up with negative 50.1 kilojoules. In our fifth step here, we need to figure out how much thermal energy the ice is now going to have to release to go from 0 to negative 5. And so we'll use C times M times delta T here. Our specific heat capacity of ice is 2.03 joules per gram degree Celsius, times our mass. What is the mass of the water? It is 150 grams. Times the change in temperature as it goes from 0 to negative 5. We'll take negative 5 minus 0, and we'll end up with negative 5 degree temperature change. Put this in our calculator. We'll end up with negative 1522.5 joules. So now we can add these up. However, the problem is that some of these are in kilojoules and some are in joules. The question here asks for everything to be in kilojoules, so we have to convert this to kilojoules. Negative 4.5 kilojoules here. This is negative 338.8 kilojoules here. This ends up being negative 62.7 kilojoules here. This ends up being the same, negative 50.1 kilojoules here. And this ends up being negative 1.5225 kilojoules here. And so what we'll do is we'll add all these up, and we should end up with our final answer of negative 457.6 kilojoules of thermal energy. So how much energy will this water vapor need to release to go from 115 to negative 5 degrees Celsius? It's going to have to release 457.6 kilojoules. If you like what you see, go ahead and click that little bomb on the bottom right hand corner. That's going to subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I hope you guys found this helpful.